Alright, hey guys, my name is Reese, and I'm going to be doing problem of the week for week 10, problem number 24 for 7.3, and this is going to be extremely long, and I apologize. And number 24 for 7.3 is this right here. The derivative of x1 equals x1 plus x2 minus x3. Derivative of x2 is x1 plus x2 plus x3. Derivative of x3 equals negative x1 plus x2 plus x3. And so you want to begin with making this into a matrix. And I feel like it's a little obvious. So, let me just... So the matrix A, so I'm gonna make it... It's just 1, 1, negative 1, 1, 1, 1, negative 1, 1, and 1. So from here, first of all, it asks to find x1, x2, and x3, basically. And to do that, you have to find the eigenvalues, the eigenvectors, and you're basically gonna use this equation to find it. The derivative of the y vector equals S inverse times the A matrix times S multiplied by the y vector. You're going to use that equation, and you also want to remember that S inverse A times S is also equal to B, but we'll get to that when we'll get to that part. So you want to find the eigenvalues and eigenvectors once again, and to do that, we're going to use this equation from our 7.1-7.2 notes. The determinant of the A matrix minus lambda times the I matrix is equal to 0. So lambda, I'm going to be super tedious and waste your time, but I am so sorry. So lambda, you can't subtract a matrix from a scalar, so you have to times it by the I matrix. So lambda times the I matrix, in this case being 1, 0, 0, 0, 1, 0, 0, 0, 1. That's going to turn into lambda 0, 0, 0, lambda 0, 0, 0, lambda. I don't know what happened there. And then you want the A matrix minus the A matrix here minus this matrix right there. And I'm just gonna shortcut it. I mean, you guys know how to do matrix subtraction, so all right. So actually, we're gonna make this like this, and then do that determinant right away, and it's gonna be equal to 0. So let me just make sure that I wrote this down right so far. Okay, coolio. And so the determinant, I mean, I'm gonna assume that you guys know how to calculate a 3x3 determinant, so it's just 1 minus lambda times the determinant of 1 minus lambda, 1 minus lambda, minus the first term being 1, and then that's gonna be 1, 1, negative 1, 1 minus lambda. And then it's technically plus, but it's a negative 1, so it's another minus term. And it's 1 minus lambda, negative 1, 1. Let me make sure I am doing this right so far. Cool. And once again, gotta remember that this is gonna be equal to 0 on the end. So, doing this, get 1 minus lambda times. I mean, I hope you guys don't mind, but I'm gonna skip all this tedious 2x2 determinant. I'm just gonna assume that you know how to do that, because you should. It's a pre-calculus thing, apparently. So it's gonna be negative 2 lambda plus lambda squared for this top determinant. Then it's gonna be minus 1 minus lambda plus 1, another 1 minus, or 1 plus 1 minus lambda for that term right there. And then this will turn to, I hate that term, sorry. This is gonna turn into negative 3 lambda plus 3 lambda squared minus 2 lambda minus 4 for the first term. So for right here, that turns into that. And then I'm going to combine these two right here. And that's going to turn into minus 4. Oh, wait. Oops. Oops. It's this term. This term right here turns into the top term right above it. The minus 4 is in the next part. My bad. So then it's going to be minus 4 plus 2 lambda for the second part of right here. I know. Oh my gosh. This is disgusting. And so just using basic algebra, you know that these two are going to cancel. You're going to be left with negative 3 lambda plus, negative 3 lambda cubed, sorry, and then 3 lambda squared minus 4. And then, unfortunately, you would have to use, the method I use to solve this for the roots. I used P's and Q's, and I'm just going to assume that you know how to do P's and Q's. This is going to be the Q's, this is going to be the P's. And hey, we're going to try negative 1. And it's going to be negative 1 on top, 3, 0, negative 4. Negative 1, 1, 4, negative 4, negative 4, 0. Oops, why did I do that? 4 right there. That's 0. And this is going to turn into lambda plus 1 times negative lambda squared plus 4 lambda minus 4. And then you know, oh, this is also, remember to make that equal 0 at the end, because that's what you want. That's what you want. And then you know that this term, you can just factor that out to negative on the outside, lambda minus 2 squared, and then it's just multiplied by the first term there. Ooh, that makes it look like, here, I'll put it on this side, lambda plus 1, that's going to equal to 0. So then, now that you know the lambdas are going to be, we're going to make lambda 1 equal to -1, then lambda 2 equal to 2, and then because the multiplicity is 2 right here, there's technically 2 lambdas for the value of 2. Alright, so from right here, almost like halfway here, guys, so sorry, you're going to use this equation from your notes, the A matrix minus lambda times the I vector times the V vector equals the 0 vector. Whoop-de-doo. So exciting. So I'm just gonna start with lambda 1, or lambda sub 1. So it's just gonna be, you just literally plug in the lambdas that you got into this right here, that matrix. So it's gonna be 1 plus 1, 1 negative 1, 1 plus 1, 1 negative 1, 1 plus 1, and then times the v vector, which is v1, v2, v3 equals the 0 vector, which is just 0, 0, 0. Then you could change that into, well, I'm going to simplify the matrix on the inside. So 2, 1, negative 1, 1, 2, 1, negative 1, 1, and 2. And then it's going to be set to 0 there. And so I'm going to switch, you're going to just do reduce row echelon form, turn this to reduce row echelon form. I'm going to put the second row at the top, just because that's just what I'm going to do. So it's cool. I'm just going to write this out. And then I'm just gonna, since the second term's already negative, I'm just gonna combine the second row with the third row. I'm just gonna leave the first one the same. It's gonna be -1, 2. Oh wait, whatever. Whatever. Okay, so this is gonna be 0, and then this is gonna, it's gonna be 3. This is gonna be 3 as well, and then you're gonna combine the second term with the second row with the first row. So that just turns into 0, 3, 3. I'll just write it right here just so you can see. So row 3 plus 2 row 2, and then row 2 plus row 1. There we go. Yes. And then you can see, obviously, that the second term could cancel out the third one. So 1, 2, 1. And then I'm also, okay, so row 3 minus row 2. And then row 2 divided by 3. We're going to do that there. So 0, 1, 1, 0, 0, 0. And then the rest is going to be here. 0, 0, 0. And then we're going to do row 1 minus 2, row 2 for this. So then that's going to be 1, 0, negative 1, 0, 1, 1, 0, 0, 0. Set that equal to 0. Okay, so then v1 equals v3 v2 equals that's the worst negative v3, and v3, we're just going to make that equal 1. We can set that to whatever we want since it's a free variable. So our first vector here is going to be equal to 1, negative 1, 1. Okay, now it's time to do the second one. So I'm going to assume that you know how to do this part now, since I did it once, this part. So I'm just going to skip to 1 minus 2, 1, negative 1, 1 minus 2, 1, negative 1, 1, 1 minus 2. Set that equals 0. And more reduced row echelon stuff. Whoop-de-doo. And then it's going to turn negative 1, 1, negative 1, 1, negative 1, 1, negative 1, 1, negative 1. And then this one's super easy, because obviously you can see that the first term, or the second term, I'm going to make that, here actually wait, I'm just going to switch that into the first row. You can clearly see that the first row cancels out the second and third row. So it's just going to be 1, negative 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. That's going to be, oops. And then you're just going to say v1 equals v2 minus v3. And then in this case, v2, going to make that, since v2 and v3 are free variables, we're going to make it just anything we want. So I'm going to say that it's S, v2, and v3 is t. And so then I'll just do it over here. So this v vector is going to be equal to s minus t, comma s, comma t, where s and t are all real numbers. And then you can also factor out the s and the t, so s 1, 1, 0 plus t negative 1, 0, 1. Same thing here, s and t are in the real number sets. And then so these two, since this v vector is a linear combination, you could just split it up into 2. So this is we're gonna call v2 the vector v2, and we're gonna make that 1, 1, 0. And then v3 is gonna be negative 1, 0, 1. Oh my god, almost done. Oh my god. Okay, so I like working on this side a lot more. So then now we're gonna go back and use the equation I wrote at the beginning. So the derivative of the y vector equals S inverse times A matrix times S times the y vector. And so S is just going to be made up of all 3 of your eigenvectors. So here. So the first one over here was that 1, negative 1, 1, negative 1, 1. It's just gonna show you. And then second one, it has to be in order. You could say, you can honestly like make this v2, make this v3, and the other one, you could have made 1, negative 1, 1, v3, or whatever. It doesn't matter as long as you have it in the order that you place it in here. It should be fine. But so mine is gonna be 1, -1, 1, and then 1, 1, 0, -1, 0, 1. That is my S matrix. I'm just gonna ensure. There we go, just so you can more clearly see that is where it came from. And remember that this is that S inverse AS, that's also just B. And in this case, B is going to be just lambda 1, 0, 0, 0, lambda 2, 0, 0, 0, lambda 3. This would just, I could write as a different thing here. I'll just be like, oh, yeah, there it is, boop, boop, boop. This is N, sure. And I don't know, dot, dot, dot. Yeah, it's technically in this form. Oh wait, I guess I would do dot, dot, dot there, and dot, dot, dot there as well. So yeah, RB in this case is going to be -1, 0, 0, 0, 2, 0, 0, 0, 2, because you got 2 twice. Remember from up here, because the multiplicity was 2. Oh my god, I swear we're almost done. We can do it. I can do it, you know. So it's gonna be. I am tired. I'm not gonna lie. Okay. So it's gonna be -1, 0, 0. Oh, oops. I forgot to explain it. We're just gonna do S. Forgot. Give me 1 second. Oh, okay. Oops. So it's gonna be. We're gonna write this int as boop, and then b times the y vector. So okay. So then okay. Cool. 0, 2, 0, 0, 0, 2 times the y vector of y1, y2, y3. So to explain this a bit more, since S inverse A S equals B, you could rewrite this right here as this, and we'll solve for that. And this is going to turn into y1 prime equals negative y1, y2 prime equals 2 y2, and y3 prime is equal to, you guessed it, 2 y2. And so using differential equations, chapter 1 over there, I don't know, you're gonna make this into y1 equals c1 e to the negative t, y2 is equal to c2 e to the 2t, and y3 is equal to c2 e to the 2t once again. Or actually, wait, hold up. It should be c3 e to the 2t. And oh my god. I'm just gonna quickly show you how to do that, how to convert this into this. I'm only gonna do one because it's essentially the same thing for all three. You just change 2 to -1. I'm gonna make it so y3. Oops. Wait, hold on. This should be y3. My bad. Okay. That looks right. This looks right so far. Okay, so we're going to do y3. And so y3 prime could also be written as dy3 all over dt equals 2y3. So using differential equations, we're going to turn that into dy3 all over y3 equals 2 dt. Differentiate both sides, not integrate technically. And so this is going to turn into ln. You know, it's going to make this y for simplicity's sake, and just like just because, okay. But just remember that it's technically y sub 3. So ln of y equals 2t plus c. You only need 1 plus c in this case. Just don't want to remember that. Give you a little reminder, and then you're just going to e both sides. So it's going to turn into y equals e 2t plus c, and then you're going to use properties of log to say, or properties of log, property of exponential functions equals e 2t times e to the c, and then e to the c, we're going to say that that's equal to c3, and then so there's going to be y, or okay, I'm just going to write sub 3 again. Okay, so y sub 3 equals c3 e to the 2t. There you go. That's how you do it. And you do the same thing for the second term. So y2, it's exactly the same, except you place y2 and equal to c2. And then it'll be the same thing for -1 as well. It's just the top term is different. Okay, so back to whatever's. Okay, so I'm gonna. So we want to remember this equation and which one calls it 7.3, I think, or yeah, I think this is in 7.3. So the x vector is equal to the S matrix, which we wrote as 1, -1, 1. I already forgot. Okay, 1, 1, 0, and -1, 0, 1. And then you're going to times that by the y vector that we just found, being these three. Being that right there. So c1 e to the -t, c2 e to the 2t, c3 e to the 2t. I'm just gonna make sure that I wrote this all correctly. That looks right to me so far. Okay, so we already have this in matrix form, technically, so she wanted it in all three forms. The second form, vector form, I think this one's vector form. So the x vector is equal to 1, -1, 1. The first eigenvector times c1 e to the -t plus 1, 1, 0 times c2 e to the 2t plus -1, 0, 1 times c3 e to the 2t. Oh my god, I feel like this video has been so long, and I am so sorry, guys. Okay, finally, we say that x1 is equal, for explicit form, you can do x1 equals c1 e to the -t plus c2 e to the 2t minus c3 e to the 2t. x2 is equal to negative c1 e to the negative t plus c2 e to the 2t. x3 is equal to oh wait, no, oops, this one's not negative. What am I doing? This one's negative, so c1 e to the negative t, and then c3 e to the 2t. And then there's our three different ways of writing the answer. This one's explicit. I think this one is what you called vector form, I think. And then this one's matrix. Okay, we're good. Alright. That was so long. I'm so sorry. Alright. Hope that helped. Have a good one, guys. Thank you so very much.